Hi, my name is Brent Tubbs. I'm going to be talking about how to build real-time web apps with a simple backend that just uses Python and Postgres. I'm going to do that in two parts. First, I'm going to talk about the why of why I would want to use this kind of architecture that I'm going to present, and then two, how it works, how you can build up a really nice reactive UI using this stack. Why will happen in a few parts itself. Why real-time, why Python, and why Postgres. First, we have to say what we mean by real-time. We do not mean the first thing on this list, which is hard real-time, where you have some specific deadline, often in milliseconds, during which you have to have completed your computation. These tend to be embedded devices. A pacemaker is a good example. If your computation isn't done by the time you're next supposed to jolt the person's heart, they could die. We are not operating at those stakes. We're in the second bullet point here, soft or near real time, where chat rooms are a good example, online games are a good example, and some other applications we'll talk about in a minute. This is still a really big step up from most web apps that are not at all real time. You have to refresh the page to see if anything's changed. Why do we want to build applications like this? I think it comes down to the user. We can really improve the user experience for a large class of applications if we can get out of that world of having to refresh to see changes and instead show the user changes as they happen. This heuristic from Jacob Nielsen is one really big guideline from a well-recognized expert on web usability on how our applications can have better user experiences. And knowing what kind of feedback is appropriate and what kind of time is reasonable is key there. So what kind of apps have real-time updates as appropriate and reasonable as a goal? Games are the obvious one. We talked about that. If you're interacting with another player who's on another computer, possibly around the world, it's really nice to be able to see their moves as they make them and let them see yours. But we're not all games programmers. A lot of us work in much more boring businesses and may wonder when we're going to have a chance to write something that is really responsive and reactive. And these other classes of applications, I think, ones that a lot more developers might work on. We may do some monitoring. And that's a wide class of things. Maybe the most common is monitoring our own servers, knowing exactly how much RAM they're using, how much CPU they're using, etc. Automation is another one that comes up all the time. You've got to deploy your software. You've got to build your software. Maybe you're automating something in the real world, some kind of machine or a robot, and you need an interface that can let you know what state it's in. And also collaboration. If people are working together to create something, they're doing that in, say, a wiki model where you view a page, then you want to make a change, so you hit edit, and you go into edit mode, and you have a text box you're typing in, and then you go to hit save. All too often, you find somebody else was editing while you were, and your changes get rejected, and you have to go merge the conflict. It's a huge pain. And if you can go from there to something more like Etherpad, where you're both just watching each other type, then these conflicts are avoided early on, and you can see other people's ideas as you're formulating your own. It's a massive improvement to be able to have real-time updates in a context like that. Why would we build this app in Python? I think Python has some things, that we could measure. We could see how quickly people understand your code base, or how extensive its library is, or how many lines of code people can write in a given amount of time. But the biggest one to me is that I think it's fun to write apps in Python. I think it's a really easy language to go from your idea to seeing it realized and really understanding what's going on, and that makes it fun. There's a similar question for Postgres, which isn't normally considered as a backend for this kind of real-time app. Usually people use something like Redis or RabbitMQ that has real-time features as front and center when people are considering it. Postgres is not often talked about in that space, but it does have an incredible reputation for keeping your data safe It's a very expressive type system and a lot of flexibility with all kinds of extensions that enable it to do stuff you might not have thought possible. Together, that makes Postgres a lot of fun too. Later we'll talk about how it can actually do the real-time stuff that maybe it's not often considered for. And lastly, why do I say just Python and Postgres in the title? If you do a Google image search for Python WebSockets, you'll see pictures that look like these that are put on the slide, where the authors of these applications have tended to split their app into two pieces. On one side will be the traditional web app, the thing that's serving pages, it's doing request response, and it's using a well-known framework like Django or Flask. And then on the other side, there's much less convention. Things are less well understood. Maybe they got Node.js over there. Maybe they've got Tornado. Maybe they've got some other custom hookup between their web server like Nginx and a back-end message broker. It's a lot of pieces, and it's a lot more complex than when you're just doing a simple web app. And I think that's really unfortunate, because I think a lot of the apps, especially ones that we write internally, like in enterprise context or just some internal admin dashboard or deployment dashboard, could benefit hugely from real-time features, but we tend not to build them in because we think these apps should just be quick and dirty, and they don't justify all of the setup and all the administration that would be required for all the components we saw on that last slide. If we want these internal apps or our weekend hacks to be able to incorporate these real-time features, I think we're going to be a lot more successful at it if we have a stack that's a lot simpler and looks a lot more like what's on this slide. Just a database in the back, your application level language in the middle, Python in our case, and a UI in the browser. That's the kind of app I'm going to show how to build in the rest of this presentation as we talk about how. As an example of how we can implement this kind of application with Python and Postgres, I'm going to take the to-do MVC app that's used in just about every JavaScript framework there is to demonstrate how it works. I'll take one of those implementations, and instead of just making it pure browser, I'll put a Python and Postgres backend on it. And if you want to check out this code, there's a link there to my Bitbucket that you can go check out and see exactly what I've done. I'm not going to go into all the details about the code in the presentation, but the whole gory details are there and you can run it yourself. To do it, we're going to need a few things. We want a REST API. This will handle our basic CRUD, creating to-do items, deleting them, listing them, updating them. We want WebSockets. Those will be the streams over which we'll get events whenever anything changes. When something is created, updated, deleted, there will be an event on a WebSocket with all the information that the UI will need to update itself. This UI is going to be built in JavaScript. There are great frameworks out there these days that can be hooked up to events and update themselves as they happen, as opposed to some kind of back-end UI that you might do with the server-side templating. To build up that UI, we're going to need some other JavaScript tools that pull down our dependencies, they compile our JS into better JS. And so we'll have JavaScript not just in the browser, but we'll have it running at build time on some server as well. Some things we don't need. We don't need server-side templating. Django templates, Jinja 2 templates that you might be familiar with in Python are not going to be a requirement for this app. We're not going to need any form handling because we're doing all of that kind of stuff through Ajax rather than through HTML forms. We're not going to need an ORM. We're just going to use some plain SQL and it will be fine. So since a framework like Django provides a bunch of stuff we don't need, like the ORM and the forms and the templates, and it doesn't provide a bunch of stuff we do, like the REST API and the WebSockets and the JavaScript integration, I think the right thing at this point in time in 2015 is to not use a framework if you're going to be writing this application. Go down a layer and just use a library that's really good at HTTP handling. I really like the Werkzeug library that underlies the Flask framework. So that's what we're going to use in this app with a little bit of code for handling URL routing and mapping routes to our handlers. For features like sessions, authentication, we can just use plain WSGI middlewares. And for supporting large numbers of simultaneous connections, which we'll need because there may be these WebSocket connections stay open for a long time, use gevent, which makes Python much more able to handle a large number of connections. Then there are some decisions I've made in implementing this app that I don't think are as essential. People may quibble with them. It's just a matter of style. And so you may notice these if you check out the code, and if you prefer to decide these issues a different way, fine. It's not really central to what we're talking about now. So in talking about the how, we want to go from the bottom to the top. Start with how we're going to get our real-time updates out of Postgres, then go up a layer to how we're going to integrate WebSockets into our REST API, then go up a layer from that to how we're going to build our UI that can use that real-time / REST API. The Postgres layer, we're going to have one table for our to-dos, and it's going to have 4 columns on it. An ID, a timestamp for when the thing was made, a title for the thing, and a flag saying true or false, whether it's been completed or not. Postgres is also going to be responsible for kicking off the real-time update when something changes. And the next couple slides will explain how that works. The first piece to that is to know that Postgres has pub/sub features built in. It has 2 commands that it has added to the SQL standard that enable this. The first is listen, where you provide a channel name, and then you should receive any updates that happen on that channel as long as you're listening. The second is notify, which is the mirror image. It's what you use to send a message on one of those channels. So in the example here, we have 2 PSQL windows, so that's just command line into Postgres. One's listening, the other sends a message, and then on the side where we're listening, we see that message as soon as we interact with the server again. In a Python driver, you don't even have to do that select one, you're automatically told. Postgres also has JSON features built in. So if we have one to-do item in our to-dos table, and we say select row to JSON to-dos from that table, then we'll get that one row back, but it will be serialized to JSON rather than getting each column separately. And that's the key line right there, is the call to row to JSON, which is built into Postgres as of 9.2, I think. So most people currently running it probably already have this. And the last feature within Postgres that lets us tie these things together is the fact that Postgres has triggers. Here we're defining a function and then attaching it to inserts and updates on the to-dos table. Whenever one of those changes happens, this function will be run, and what this function does, the meat of it, is right there. It'll perform a PG notify, which calls that same notify command we saw earlier. This is just alternate syntax. Send a message to the to-dos updates channel, and then the payload will be that new row, whether it's newly inserted or newly updated, cast to JSON. Before we leave the Postgres portion of this, a few caveats about scalability. Postgres can handle up to a few hundred simultaneous connections, and for our purposes that means it can handle up to a few hundred WebSockets connected to our app at the same time. If you're on Ubuntu, you probably want to raise the max connections. 100 is a little lower than Postgres in support, maybe set it to 4 or 5. For thousands of clients, well beyond what Postgres can handle, you would want to have some other kind of queue. So maybe you have a process that listens to Postgres for the updates and forwards them to RabbitMQ, where then that can fan out to a much larger number. And finally, there's a limit on the size of the payloads we can send in this pub/sub. they cannot be larger than 8,000 bytes. For our to-dos application, we've ensured that it can't get that big because our table, 3 of these columns are just inherently limited in their size. The UUID, the timestamp, and the completed flag have built-in limitations, and then on the title we said it will be a varchar 512, so it can't be longer than 512 bytes, and we know that that's going to come in well under the 8,000 byte limit once any of those rows is turned into JSON. So move up to the Python level, and this is how you can subscribe to one of these Postgres pub/sub channels from Python. Just open up psychopg2. You have to turn on auto commit, otherwise this won't work. It means you're disabling transaction support with like begin and commit. You get a cursor and then you execute that listen command that we saw earlier. Then you go into while loop and you just do a select on the connection and wait for some event to happen, and we pass in a timeout of 5 seconds saying if nothing's happened in 5 seconds, then return and let me do some stuff, and then I'll go back into my loop. If something has happened, that means you've got an event, and you can pop that off of the con.notifies list and do something useful with it. This example just prints it. I had pasted this example from the psychopg docs into my different projects so many times that a little while back I decided let's make this a module so that it is harder to get wrong and we don't have to write the same code over and over. So everything to do with setting up auto commit and the timeouts and yielding out events into a nice iterator can be handled by this pg pub/sub package that you can just pip install, import, and use like this. And if you go to that URL on PyPy at the bottom of this screen, you can see a README about how you can do a little more advanced stuff like listening to multiple channels, how you publish notifications with it, and so on. So if we run either of those Python scripts, either the one straight out of the psychopg2 docs or that example from pg pub/sub, and then you have another window open that's PSQL where you send a notification, you should see it printed out to your bash terminal just as soon as the notification is sent in Postgres. That's how we handle the real-time updates at the Postgres layer and then up into the Python layer. Next, we want to expose all that in an API, and we want to integrate the REST API that handles our basic creation of things, deletion of things, updating of things with our WebSockets that do the events on when any of these things has changed. REST APIs are pretty well known. There's arguing people may do around the edges about how purely hypermedia they should be, but the basic methods and what they should mean, I think there's pretty good consensus on it. If you want to create a new to-do item, post it to /API/todos. If you want to get the whole list, go to the same endpoint but do a get method. If you're just looking at one to-do item, then get it at the same path but add the ID on the end. And if you want to update that item, use the same path with the ID but use the put method. Same for if you want to delete it, use the delete method. That's all pretty uncontroversial, I think, but it doesn't tell us what to do if we have these real-time streams of events. This is where I want to coin a term. The term is RESTSockets. Take REST, add WebSockets to it to get real-time updates on the same resources that are being served out of the API. So if you want a stream of all changes to all to-do items, then make it a WebSocket request to /API/todos. If you want a stream of changes to just one item, then do a WebSocket request to the same endpoint where you would just get the information for that item. That's the RESTSockets pattern. It's what's used in my example app, and I think could be a powerful way forward for people who already have REST APIs or are already familiar with building that kind of app and just want to add in real-time update features. In Python, in the mini or micro framework that we've built inside this app, this is what a view or a handler would look like. We have methods for all those traditional HTTP methods like get and put and delete, and we just add one for WebSocket. So if a request comes in that wants to get a WebSocket stream, it's handled in that function on that class. A put looks like this. As I mentioned, we're using raw SQL, so we just take the data as it came in, parse the JSON, use it to update the item being referenced, and in case the ID changed, we return a redirect to the new thing. The WebSocket method, by contrast, doesn't return a response object. It actually just sits in a loop waiting for events to come out of Postgres, and every time one comes, it does one of these self.ws.send, sends that payload that came. There's a little bit more complexity going on here with these ping lines, ws.send frame, then an empty string, and ping. And that is to handle disconnects. When somebody has opened up your app and they're watching some things change and then they close the tab or they close the browser entirely, your application code doesn't get any kind of disconnect message about that. The only way you're going to know that the client has disconnected and the socket's closed is if you try and send something on it. So PG_PubSub, which I'm using here, has this option, yield timeouts equals true. And that means every time we get that 5-second select timeout from lower level where we're connected to Postgres, it'll bubble up to our level and we can send a ping over the WebSocket. And then if it turns out that the WebSocket's disconnected, an error can be raised and we can handle cleanup, make sure that we haven't leaked Postgres connections. So that's why we're being really conservative, making sure we're always sending regular pings so that if the connection goes away, we can clean it up right away. That's the trickiest part that I found in getting applications like this to work. So let's demonstrate how this API works. We have a window in which the application is running. Looks like I might have killed it though, so let's just check that. 8,000. It's still running, so that's great. Let's hit the API. Let's make a new thing. I'm going to use the HTTP tool, which is really great. I'm going to say let's post to port 8000/API/to-dos. And what's really great about this HTTP command line client is I can just tell it title equals a thing, and its default way of handling that is to make a JSON object out of it. So it's really going to have a JSON object with a key called title and a value called a thing, and it's going to post it up to this endpoint and set the appropriate content type. I do that, and I'm getting a redirect back that told me it made the thing, and now it's redirecting me to the location where it now lives. So this is the ID of the new thing, and it wants me to go visit it there. So that's great. Let's list all our things. So HTTP get port 8000/API/to-dos. And here we see that thing we just made returned as the only object in this list, and our title's there. These other three fields, as I mentioned, were automatically populated by the database. Next, let's do these streams. So we're going to bring in another window. And here we'll make a WebSocket connection to that same endpoint. That's going to look a little bit different because this is the WSCat utility. You can install that with npm. Localhost 8000/API/to-dos. That's the same endpoint that we were hitting. If we want to create things, you'll see it immediately streams out that one thing that we've already created. But if we're going to make another thing, as soon as we create that, we also get that event right in our WebSocket. That's how our API can marry these two different concepts, event streams and RESTful routes and methods together in the same place in a way that I think is pretty intuitive and be easy to understand for anybody who already has worked with REST APIs, and that's quite a lot of developers out there. So that's the API layer. We've got one more layer to go. It's how we're going to build a user interface on top of this API. There is no shortage of choices in this space. For this application, I made the choices highlighted in green, but I only really want to highlight two of them here, and that is using React as the front-end framework for doing the actual rendering of our components, and using a Makefile to tie together all our JavaScript build tools, our Python build tools, so you can just have one command, make dev if you're doing a dev environment, or make JS if you want to build up the whole JS environment. And everything will just flow out of that through Make's dependency-based structure. React is a particularly nice fit for the kind of application we're building here because it rejects the two-way data binding that has long been a feature of frameworks like Angular and Ember. It says we're going to have it be just one way. You'll have one source of truth about what the data is, and then the UI will basically be a mapping. From whatever that state is, the UI will just be the result of a function. So for us, that means we can say, well, we'll just feed in that stream of information to the React app. It will turn it into user interface and put it in the browser. As people click on things, then AJAX calls will be made to our API, which will then send SQL down to Postgres. Changes will be made at the database layer, and those will be reflected as notifications that come back out over the same WebSocket. So the one-way data binding in React just allows us to connect that end of the loop in the user interface. The Makefile is the other piece of putting together this application that I think I'm most happy with. This flowchart is more complicated than the others we've looked at in this, even more complicated than the complicated stacks we were trying to avoid. Thankfully, this is dependencies at build time rather than at runtime, so runtime we still get that simple stack with just those three layers. But the reason this is complicated at build time is because we're spanning two different ecosystems. We've got Python that is using pip, and we've got Node, which is using npm. We use a Makefile to span that gap. So first thing we do is in pip, in our Python environment, we install a package called nodeenv. Nodeenv then knows how to install a Node environment into your Python environment. So we use that, and it gives us npm. Then with npm, we can go out and get these other tools like the React compiler. It'll take our components, our UI components that are written in React.js language, and it'll compile them down to plain old JavaScript. npm gets Bower, that's then going to go fetch all of the stuff that's going to run inside the browser, the third-party things that we don't need to do anything with other than serve them to the user before we serve them our own code. And we get uglify, so that is a minifier that takes our compiled JS and our compiled JSX and the plain JS that houses our model, and concatenates them together, minifies it so it's nice and efficient to serve out to the client. This brings us then to a demo of the UI layer. Here, start with the browser. This browser window has been open in my other screen the whole time we've been presenting, and so you see it's already got a thing and another thing. And I can easily add a third thing immediately shows up, but that's still going through that whole loop down through the API to Postgres and getting broadcast back up. I have two browsers here. You can easily type in a fourth thing, and you see that show up in both the browser windows at the same time. They're both subscribed to the same WebSocket endpoint. But what's even more fun to me, and I could waste 10-15 minutes at a time messing around with this, is to show how it's connected to the browser. So if I connect PSQL, command line client for Postgres, and I write a command like this. I'll say insert into to-dos title values make real-time web apps simpler. It's inserted and it's immediately shown in the user interface. If I say update to-dos set completed equals true where title equals make real-time web apps simpler. Completed. Delete from to-dos. All cleaned up. Our user interface is always in sync with the database, which is our true source, our one source of truth about the state of our application. And not only is the user interface always in sync with it, but everybody's user interface who's looking at the same app is always in sync with it. To summarize, we can build real-time web apps with just Python and Postgres by using triggers within Postgres to notify Python of changes happening at the database level and putting WebSockets on top of those notifications. Use as little framework as possible because today's frameworks have a lot of stuff we don't need and don't have a lot of stuff that we do. Use the RESTSockets pattern so the API is easily understood and approachable for anybody who's used a REST API in the past. Don't have to reinvent the wheel with a doing everything over WebSockets protocol. Use React.js, or today frameworks are increasingly migrating towards React.js's style. Angular 2, I think, is going to move to a unidirectional data flow, and possibly Ember as well. It feels like the future, but React has it right now. And use Make to tie together these different stacks. That gives you the advantage that it's not being replaced with the new JavaScript task builder of the week, as you may have seen, the movement from Grunt to Gulp to, I think there's something called Broccoli now. Make is almost everywhere, and it can handle this in both the Python and JavaScript context really nicely. That's the presentation on how to build real-time web apps with Python and Postgres. If you have questions or comments, feel free to email me at brent.tubbs@gmail.com, and you should be able to get these slides at the URL at the bottom of the screen. Thanks.